Generally don't like to have a lesson night before you actually write. But there was a request that we actually do this lesson, so I'm going ahead and doing it. I'm going to focus on just a few random questions, questions that I haven't answered, or types of questions that I haven't done. And I'm going to take them across the board. Please ensure that you go over components and equilibrium, because those questions are going to take a lot of time and they're very easy marks. I don't think they're going to be difficult. Okay, the person who's got his mic on, please put it off.
Ai,
All right, let's start. All right, that's a bit weird. I've sent a large number of questions my way. I don't think they have been yet. All right, there's the first question coming up.
See.
Yes, sir.
Sir, by your judgment, do you think the four-spot diagram will come out?
No, I don't think so. But please don't take my word for it. They generally won't repeat a question from the previous year if they've already tested it.
Yes.
So I think it'll be a normal equilibrium question as opposed to a four-spot type question. No, that's not it. But what was nice about this question here was the way the examiner actually asked it. And we didn't do too many of these types of questions anyway. So it would be good practice for us to actually do this particular question. Only those that actually came. Oh, actually, you didn't come. The day I did a question like this, only the grade 12s pitched up on the Thursday. No grade 11 pitched up. Right, let's start. Two blocks, M and a 6 kilogram respectively, are connected by a light inextensible string. The string runs over a pulley. Initially, both blocks are held stationary, so the initial velocity of both the blocks is 0. At the same height above the ground. When the blocks are released, the 6 kilogram accelerates downwards. And obviously it means that M then accelerates upwards. So that's one of the catches in this type of question, is that these two exhibit opposite directions of acceleration. And this is where 90% of the learners fell for the trap last year. It says the vertical distance between the blocks 1 second after they are released is 1.96 meters. So 1 second later, when these two start moving, this is the distance of separation between M and the 6 kilogram. That distance of separation between them is 1.96 meters. Anybody wants to make a comment on this? In the 1 second, how much did each actually move if they were 1.96 meters apart after 1 second? Let me repeat the question. Maybe it wasn't phrased very well. 1 second later, they are 1.96 meters apart. How much did each of them cover so that the distance of separation between them is 1.96 meters?
So,
Yes, sir.
0.98 meters.
And how did you get that, sir?
So, since M and the 6 kg were on the same, they're on the same. So when M moves and the 6 accelerates downwards, they accelerate and M moves at the same acceleration. So the distance
Very good.
of 1.96 divided by 2 would give us 0.98.
All right. So there's several things you mentioned there, which is correct. Firstly, they both started at the same level. Both of them had it. The person who came in now, please, can you just put, this is such, I can't understand why you people, God, man. Ntando, please, let's not do that again, right? They started at the same level. They have the same acceleration. They both have the same initial velocity. So therefore, each one would have covered exactly half of this total. Same acceleration, same initial velocity, starting at the same level, means both of these traveled only half of that distance to give you the total distance to be 1.96. That means this basically started from here, went up 0.98 meters, and this went down 0.98 meters. All right, question 2, state Newton's second law. So if you want to know whether this is going to come out, I would put my head on the block and say Newton's second law is normally going to come out. So please learn that as a definition. 2.2, label free body diagram showing all the forces on the 6 kilogram. Right, for the 6 kilogram, please listen up because the 6 kilogram is accelerating downwards. You're going to have a downward gravitational force and you're going to have an upward tension. And the gravitational force is going to be larger than the tension because it's accelerating down. Then we have M over here. M is accelerating up. So that's going to have a larger tension and a smaller gravitational force. By the way, I made it look like one T is larger than the other, but it's not the case. Both the T's are exactly the same. It's the same tension, just acting on two different objects. Remember, the 6 kg is accelerating down and the 4 kg is accelerating up. You need to remember this because you're going to set up two equations and solve it simultaneously so that we can actually get the mass of this unknown object here, which is M. 2.3, calculate the acceleration. For you to calculate the acceleration here, you're actually going to use an equation of motion. You got your delta x, that any one of them actually go up. The delta x is half of 1.96, which is 0.98. Your initial velocity is 0, and your delta t, or your time, is 1 second. Your delta x, 0.98. Your VI is 0. Half into a into 1 squared. Multiply both sides by 2. You're going to get the acceleration to be 1.96 meters per second squared. And there's your acceleration there. Please note it said acceleration for the 6 kilogram. The 6 kilogram, boys and girls, is going to accelerate downwards. You have to stay downwards here. 2.4. Determine the value of m by applying Newton's second law to each block separately. So we want to determine the mass m. So let's start off with the 6 kilogram because it's accelerating downwards. So we're going to go F net equals ma. That's your positive force. That's your negative force. Why? Because it's accelerating downwards. You take the downward forces to be positive. So Fg plus minus T equals to ma. Your Fg will be 6 times 9.8. Your T, we don't know. Your mass, 6, and the acceleration, 1.96. So from here, T is 6 times 9.8, please. 58.8. 6 times 1.96, someone? 11.86.
11.76, sir.
76, thank you. So that's your first equation. Your second equation is for m. Again, F net equals ma. Sorry, I should have actually asked you this question. Why do we not have a normal force on either of the masses here?
Because that's not on a surface.
Very good, sir. If these blocks are not on a surface, if they're hanging in the air, they are not going to have a frictional force on them. Sorry, a normal force on them. So here, be careful because here it's accelerating upwards. So it's going to be T, which is your positive force, and Fg, which is your negative force. In other words, let the forces in the direction of the acceleration be positive. So it'll be T plus minus Fg equals ma. T minus m times 9.8 equals to m into 1.96. So take everything across. T equals to 9.8 m plus 1.96 m. Sorry, I should have worked out T over here on the top. But foolish of me. 58.8 minus 11.6, someone? 76? What's the value of T there?
47.04.
Thank you. So we'll now put 47.04 in place of T here. (9.8 plus 1.96), someone? (11.76).
Yes, sir.
47.04 divided by 11.76, please.
4, sir.
4, exactly. Okay. Right, we can't do the last one technically, because we need to know a little bit about free fall, but I'm just going to do it. The string connecting the blocks is now cut. What will be the magnitude of the acceleration of m if the only force acting on both of these blocks is the force of gravity? Then both of them will have an acceleration of 9.8 meters per second squared downwards. That was a nice question, actually. Because we haven't done any equilibrium question, I'm just going to show you what an equilibrium question would actually look like. So if somebody asks me what I suspect would come out for forces, obviously you're going to get one of those component questions on the Cartesian plane. But the second question should be a nice question with equilibrium in it. I'm hoping we got an equilibrium question here. Yeah. So I would bank on something like this coming out. Not a force board. But so let's talk about T1 and T2 before we start. Boys and girls, if they have hanging masses here on the sides, those hanging masses will have a weight. You will work out the weight. Yeah, they've worked out the weights for you. Those weights will basically be the tension in the two strings. So if I ask you what's the tension here called T2, that tension T2 going upwards towards the pulley is 660 newtons. What's the tension here T1 going towards that pulley there? That's 381,05. And as I told you before, at grade 11 level, we generally work with right angle triangles, so they gave you a nice neat 60 degrees and 30 degrees. But to be very honest with you, the way this question was structured, it didn't have to be a right angle triangle. It could have been anything. One of the things that I like to do when I'm given a question on equilibrium is find the point where the three forces meet, which is going to be there. Your third force is going to be the gravitational force associated with mass A here. I'm going to draw in my horizontal line. That horizontal is going to be important because I'm going to use that in my calculation of either angles or sides of my triangle. Now, if you read very carefully, these two questions deal with components. And one of the things I want to emphasize about components is that based on the formulae you've learned about components, you're going to have to use the angle with respect to the x-axis. So that 30 degrees there and that 60 degrees there is what you're going to use to calculate the components for T1, which is T1x here and T1y there. And then for T2, that's T2x here. And that's T2y there. Because the system is in equilibrium, the horizontal components will cancel out the effect of each other. And also, what will cancel out the effect of each other are the vertical components. In other words, T1y plus T2y added together will equal to the gravitational force of mass A. What is the resultant force on the system? Well, it's in equilibrium. We know the answer to that. The resultant force is going to be 0 newtons. I'm not going to state Newton's first law. You should all be able to state that. Remember, one of the important sort of facts that emanate from Newton's first law is that if the net force on an object is 0, the object can remain at rest. And here we have a scenario where the object is in fact at rest. Right. Calculate the components of the force in string T1. They said components of the force. That means they wanted both the X and Y components of T1. So I'm going to do 2.3.1. T1x is going to be T1 cos theta, which is 381.05 cos 30.
$330 sir.
Exactly. So 330 newtons exactly?
No, rounded off, sir.
Oh, okay. What?
329.99.
Okay, so 99, what's the third decimal?
998.
Okay, so it's 330 exactly then. And T1y,
So I have a question.
yes, sir.
So for the x component of T1, do we put it as negative 330, sir?
I'm going to come to that, sir. I didn't put down the directions for a reason. T1y, anyone?
190.53.
190.525.
Oh, come on, man. What's it, 190, come up?
53.
Let me explain why we should round up to 2 decimal places. Because technically that's the end of the question. And that's the end of that question there. When it comes to these negatives and positives now, I think you need to be a little wary. Because I think what this examiner meant to state was the magnitude. But he didn't. So here, I think we should just put left or right. But you need to know that your left is going to be negative, your right is going to be positive, your up is positive, and your down is negative. The reason why I want to just stay away from the pluses and minuses now is because technically, if we say left is negative, then we can't say down is also negative. So they normally always ask for magnitudes. I don't know why they just left it out here. And then similarly, 2.3.2. Components of the string T2. So T2x is T2 cos theta, which is 660 cos 60.
Also
330.
330.
Yeah, so that's going to be 330 to the right. And then T2y will be T2 sine theta.
So
Yes, sir.
571,58.
Okay, someone is going to ask a question there.
so for our typical vector diagram, so like when they give us like two or more vectors in a diagram, and we're supposed to work out the resultant of all the three vectors, for example. Is that when
Yeah,
we
then
can
you'll put
include
in
the
you'll put in the
negative?
pluses and minuses, sir. But that's not on equilibrium, by the way, yeah?
Yes, sir.
That's a resultant question that you're talking about.
Yes, sir.
But here they didn't ask for a resultant question. So the paper didn't have a question on resultant here. Yeah, so if it's a typical question about what you're talking about, I agree. You just put the pluses and minuses on the table and you work it out quickly. Yeah, they specifically asked for these questions, right? And because they specifically asked for the components, I actually worked it out. Now, I don't know why they get so many marks for this. This was just a repetition question. So T1y plus T2y is equal to FGA here. So let's start there. 2.3.3. T1y plus T2y is equal to the gravitational force of A. So T1y plus T2y is equal to the mass of A times G. T1y, we worked it out, 190.53. T2y, we also worked out, 571.58. And that's going to be the mass of A multiplied by 9.8. So add the 2 on the left-hand side divided by 9.8 and you got the mass of A.
77,77 kilograms.
You can put your mic off, thanks. So that would be a nice question, but normally it doesn't come out as a component question, eh? You know that normally it comes out as a triangle question and you're going to draw a closed vector diagram for that. All right, let's take another hard question. I hope those questions are actually are all here now.
So
Yes, sir.
for tomorrow's test, can we expect
Yeah.
the trolley practical thingy to come up with the graph?
Yes, sir. Weirdly, I thought it will only come up once, but it came up twice last year. So my suggestion is make sure you go over it. I think it's there's a great possibility that it can come out. Okay, this paper is filled with electrostatics. So you can get a question like this here. This is a very easy question where you got 3 vectors and you are basically finding the resultant there. I don't like these ones. These ones are too easy. I don't like that either.
Facts.
Yeah. But I'm going to spend the last 15 minutes doing multiple choice.
Please.
I like a question like this here. And I'll tell you why. If I was setting an exam and I want my learners to actually uh, gain some marks, This is one of the most popular questions in Newton's laws. So I would bank on something like this coming out and an inclined plane coming out. One would be on Newton's first law, and the other one would be on Newton's second law. And I would put both double masses. So this type of question and an inclined plane, if you're actually doing some last minute studying and you wanna, I don't know, pray that it comes out.
So
Right,
what
let's start.
about for Newton's third?
Newton's third law
So
is normally a theory question in
what
Newton's
the
third law. I don't think they'll give you the two masses touching. I don't know. I just got a feeling they won't. So for Newton's third law, we did two questions. We did one where you had an inclined plane and you had two masses touching. And we did a horizontal question with two masses touching. Now, if you're wondering whether this came out, it did. I think it came out in 2019 or 2018. This one here came out. This has never come out. Ever. So I hope it's a kind examiner this year and he's basically checking to see that you know your work and not trying to trick you. All right, let's start. A 5 kilogram block resting on a rough horizontal surface is connected by a light, inextensible string passing over a frictionless pulley to a second block of mass 3 kilograms hanging vertically. An applied force F is acting on the 5 kilogram as shown in the diagram below, and the coefficient of kinetic friction is 0.2. The 5 kilogram block accelerates to the left. That's very, very important. If that accelerates to the left, means the 3 kilogram block accelerates upwards. Oh, interesting. They didn't ask for Newton's second law here. They asked for the definition of a frictional force. Please make sure you learn all your definitions, eh? Right. Draw a labeled free body diagram to indicate all the forces acting on the 5 kilogram. Now, I'm a die-hard fan where you actually have to draw your components. So there's my Fx there. There's your Fy there. And then you fill in the rest. So we're going to have your gravitational force, your normal force, your tension, and your kinetic friction. This is for the 5 kilogram. I'm going to draw the 2 kilogram as well. Remember, I told you, you will always need both the free body diagrams. Yes, sir.
Would you not need to state the applied force since there is an applied force on the 5 kilogram block?
No. You either put the components or the applied force, or you put the applied force. Sorry, if you're putting the components, you don't put the applied force. If you're putting the applied force, you don't put down the components. So I'm hoping we got the memo with this. It should have both possibilities there. Okay, so they didn't show the other one over there. Right, but I would actually draw the components as opposed to the applied force. If you look at the matric exam, final exam, if there's a force acting at an angle, they give you two options. One is to draw the components, or one to draw the applied force itself. I just prefer the components. There's your direction of your accelerations there. Right, what do they tell us? They tell us that the vertical component of F is 38 newtons. Yo, they gave it away. The vertical component of F is 38 newtons. Oh, sorry. Calculate the magnitude of the vertical component of F. If the magnitude of the horizontal component, sorry, did the whole thing wrong. Calculate the magnitude of the vertical component of F. If the magnitude of the horizontal component is 38 newtons. I just want to show you on this diagram an easier way to get that vertical component. So if you've got this fx sorted out here, and the examiner gave you that fx is 38, and they want you to find fy, you can actually just put fy here. Just to make your life easy, because they only gave you 2 marks for this. And I'm trying to use the mark scheme for it. And to find fy is your opposite, fx is your adjacent. You can actually use tan of theta. So for 3.3.1, you can say tan of theta, which in this case is 20, is your opposite. Your opposite is fy over your adjacent. Your adjacent is fx, and fx is 38. So fy is 38 tan 20. What's 38 tan 20, anyone?
Thirteen comma eight three.
13,83. So there's fy. Okay, so they asked you some nice questions here now. Calculate the normal force on the 5 kilogram. They deliberately went out of their way to do this because they knew learners won't see it. Your normal plus your fy added together is equal to fga. The norm Somebody ask him to keep quiet, please.
Please turn off your mic. Zoom user, please turn off your mic.
Fy plus fn is equal to fg. So your normal is fg minus fy. Your fg is mg, and that mass is 5. So it's 5 times 9.8 minus your fy. And the fy was 13.83. What's the normal force?
So 35,17.
I'm going to leave this out. And before we start with calculating the tension in the string, we need to get the kinetic frictional force. So I'm going to do that first for 3.4. Your Fk is going to be equal to mu k times n. The mu k was 0.2. The normal was 35,17. So what does that give me? 7.34.
03.
03. Okay,
Yes,
thank you.
034, sir.
Okay. 03 is fine. We don't need the 034. Right, now to get the tension in the string, we're going to set up our two equations and solve it simultaneously. So we're going to go F net equals MA. This is for the 5 kilogram. And for the 5 kilogram, it's going to be Fx plus minus your tension plus minus your kinetic friction equals to MA. Let's have a look at that again. Fx minus your tension minus your kinetic friction. And Fx, I think we worked, was given to us, 38. We're going to find this tension. My kinetic friction was 7,03 equals to 5A. Thirty-eight minus 7,03, someone? 30,97. But for now, I'm gonna just leave that as it is. And then I'm gonna go to the 3 kilogram. So for the 3 kilogram, it's gonna be F net equals MA again. But because it's accelerating upwards, it's gonna be your tension plus minus your gravitation equals MA. Your tension plus minus your gravitation equals MA. Your tension is what we want to get. Your gravitation is 3 times 9.8 is equal to 3A. So your tension minus 29.4 equals 3A. Now, I like solving T without solving for A. That's just a preference with me. I've got 5A here, and I've got 3A here. My aim is going to be to eliminate A. How do I eliminate A? I multiply the top equation here by 3, and I multiply this bottom equation here by 5. If I multiply the top equation by 3, 30.97 times 3, someone? Anyone?
92,91.
Let's take a, okay, yeah, right, should be that, right. And then the bottom equation by 5. So we're going to get 5 ft, 29.4 times 5, please.
147.
Thank you. So I got 15A for both. I equate the left-hand sides now. 92.91 minus 3 ft equals to 5 ft minus 147. So 8 ft here. 92.91 plus 147 divided by 8. What's ft?
29,99, if I'm not mistaken, sir.
Thanks. All right, let's do some multiple choice questions.
Sir,
Yes, sir.
So in the test, if you choose to solve for t without solving for a, do you have to show that you multiplied the equations, or could you just write out?
No, but you have to multiply it. You don't have to show what you multiplied it by. But you have to show that you've eliminated it somewhere along the line.
Okay, thank you, sir.
So,
Yes, sir.
so back to the A, sir. So must you make the A equal to the other A, sir? Or
That's what we
would
did, sir. We did exactly
or
that, sir. We made them both equal to 15A.
would you ever be in a situation, sir, where we have to multiply both the A's in order to get like the same A?
We did that, sir.
No, so
We
we
did that
only
in this
multiply.
question. No, sir, we
We only
multiplied both, sir. Somebody still got their mic on, man. Come on, man. Here's it here, sir. We multiplied this equation by 3, sir, to get 15A, yeah. Then we multiplied this equation by 5, sir, to get 15A again, sir. So to get the same A, we multiplied both the equations, sir.
Thank you, sir.
So,
Yes, sir.
can you please just go over this equation just slightly one more time so I can understand properly?
Which equation, sir? Okay, do you know how we got the 15A, yes, sir?
No, sir. Sir, I wasn't here when you started this equation, sir. So,
That would mean I'd have to go through the whole question, sir. May I suggest you watch the recording, sir? Because we got like 5
yes,
minutes
sir.
left before we actually listen. I'll put up the
Okay, thank
recording
you.
at 9 p.m., 9:15. So I have another lesson after this.
Okay, thank you, sir.
No problem. So somebody will actually put up the answers to this, and I'm going to put up the multiple choice questions now so you can actually try it on your own as well, because I'm only going to be in a position to do a few of them. There's a really good module that you could actually use, which only has multiple choice questions in it. So let me share this now. Somebody still got their mic on. And it's quite actually loud. Maybe if you try putting something over your mic so you actually reduce the intensity of your volume on your side.
Sir,
Yes, sir.
so Mr. Chetty told us that if the paper comes with a magnetic field question, y'all will replace it with the normal electrostatics question that
I've
y'all have
already
set.
done
Is
that.
that true?
I've already done that. I'm doing that part. So it's
Okay, thank you,
already
sir.
done, right? And the reason
Yes,
for
sir.
that is because Mr. Naidu's class actually is not going to get to where you guys are. So we put a very easy question for Coulomb's law only. So you go over last year's work, please, plus a very basic question on this year's work.
Thank you, sir.
Right, what's the answer for 3.1? A car of mass m collides head-on with a car of mass 2m. If the car exerts a force of magnitude F on the truck during the collision, then the magnitude of the force that the truck exerts on the car is object A applies a force on object B. So
B.
object B applies. Very good. It's B. That's an action reaction pair. You can't answer 3.2 because it deals with momentum. You didn't do that as yet. 3.3. The following diagram shows a racing car R driving along a straight line to the right. The driver of the racing car applies the brakes. When the car reaches the oil spill at position P, in which direction will the car R slide? That's an easy question now.
B.
Very good. It'll still move forward, isn't it? Why will it still move forward?
So there's a smooth
Principle of
surface.
inertia.
It's inertia, yes. Right, let's give you a hard question. I'm just going to look for a hard question. Here, 312. A constant force Fa acts on an object, causing it to move at constant speed over a rough horizontal surface, as shown in the diagram. How does Ff compare to Fa?
C.
Very good. Your Ff will be less than Fay.
So because it's moving.
No, sir. It's moving at constant velocity, sir. What is Ff equal to here?
FA, but in the opposite direction.
It's equal to Fax, yes. Now, what's the formula for Fax? Fa cos theta is equal to Ff. And if you don't know anything about cos theta, for any value of theta greater than 0 and less than 90, did you notice something about the cos graph? The cos graph for 0 to 90 looks like this. That means it's less than 1. By the way, that's the maximum value of your cos graph, if you didn't know that as well. Which means if you take any value of theta between 0 and 90, your cos graph will have a cos theta value which is less than 1. And if this is less than 1, then Fa times any value less than 1 will be less than Fa itself. So therefore your Ff will be less than Fa. So the answer is C. That was not a very nice question. Where was the other one? Yes, you will definitely get one of these questions over here where you're comparing. Can you do this one? 318. Two hypothetical planets X and Y have the same mass. The diameter of Y is twice that of planet X. If the acceleration due to gravity on planet X is g, then the acceleration due to gravity on planet Y is? What factor are we changing here? The diameter of Y is twice that of X. What does that mean about the radius?
The radius doubles, sir.
Obviously, the radius will double as well, exactly. So, for those of you that don't know this or don't remember this, G is equal to Gm over R squared. It's inversely proportional to your R squared, so it'll be G equals to 1 over. If you double the radius, you're going to have a new factor of 2 in the bottom, so it's going to be 2 squared. So your new G is going to be 1 over 4 the original G, which was the G of X. So the answer there is B. Right. I just want to explain something so we all get this clear. I don't like taking any queries late at night on the night before you write. The simple reason for that is I don't want to get stressed out by how much you don't know. Right? I think I've done enough on my side. So I'm going to have a good night's rest tonight. I got another class after this. If you got a question at this point over here, you're going to have a bit of an issue. Because this is where we actually end for tonight. Right? So try, please, as much as you can, not to drop me a message at 10, 11, 6 a.m. in the morning about any query that you have. Right?
Thank you, sir,
You'll
for
see.
making time for this lesson.
Do we have a lesson tomorrow in class? Oh no, we don't, do we?
Performance test.
Yeah. Do I see you in the first or second period? If I do, you can bring it over there in the first or second period,
Lesson.
right? But don't message me in the middle of the night with a query, please. Thank you guys. Best of luck for tomorrow.
Thank you, sir.